Good morning. How's everybody doing? Good. We have a couple minutes before 9, so I'll start sharing in a couple minutes. All right, so it's 9. I'm going to share my screen for a warm up. And then when everybody else gets here, we will do a Mindfulness Monday activity. All right, can you guys hear me and see my screen? Can you guys hear me? I feel like you can.
I can hear you.
Okay, great. So everybody get your cameras on and try these warm-up problems. Where is everyone today? Everybody getting a slow start, except for those of you who are here. All right. Does everybody have an answer to the first one? In how many ways can you choose a president, secretary, and treasurer for a club from 12 candidates? If each candidate is eligible for each position, but no candidate can hold 2 positions. Everybody have that answer? All right, let's put it in the chat. 3, 2, 1, go. Nice job. Those of you that didn't put your answer in the chat, what's going on? Are you not done yet? Or do you have a question on how to do it? Yep. Very similar to the exit ticket that you had last week, right? So who can explain how they got 1,320 ways? AJ, how'd you do it?
Oh. Number one, right?
Yep.
Yeah, 12 candidates, 3 positions, only 1 position in each, so 12, 11, 10.
Very nice. And you could do the lines if you want, right? Because we're choosing 3. Did anyone use the formula? You could use the permutation formula where it's 12, choose 3, right? And you could do it on the Desmos calculator. Look at all that stuff I have open. That's weird. That's okay. Let's go to 12. Oops, nope, on this one I have to choose the function first. So I go to function, choose NPR, and choose 12, 3. And there's my answer, 1,320. So I don't care which way you do it, if you use the permutation formula or if you just think about it, that's totally fine, as long as you can write down your work and show me what you did. All right, so a pizza place has pizzas in 3 different sizes and 15 toppings. How many 1-topping pizzas can be ordered? So how about this one? Let's get your answer ready in the chat. So this is the answer to number 2. 3 sizes of pizza, 15 different toppings. How many 1-topping pizzas can be ordered? 3, 2, 1, go. Only Valerie has the answer. There we go. Now I see another one. There we go. So were some of you hesitant because you thought maybe you were supposed to use the permutation formula on this one? This is just a basic counting principle, right? So it's just 3 times 15, which is 45. Because this time we're just counting them, right? All right. So you guys seem a little sluggish. I don't know if you are checked out for the rest of the semester, but a lot of you can't afford to check out for the rest of the semester, right? You need to pass this class, right? I mean, I'm just guessing that you need to pass. So you need to, it's ever since we came back from that extended spring break. So let's check back in and make sure we can do it. Because I just checked, not one person has put up a video for the review yet. Not one. And a lot of you are going to be like, oh, wait, it's not due till tomorrow, right? Yeah, it's not due till tomorrow, but what did you do before? Because you guys are going to have a lot to do, right? You have a quiz on Thursday. So be careful. You're making me nervous. That homework wasn't easy, was it? For PC6, was that homework super easy? No big deal? I'm not sure. Some of you are like, only Valerie was like, homework was fine, right? Like I could see it on her face. Kind of easy, Ashley said. Some of them were hard.
I got like over half of them right, and then I hit like a couple that I got wrong. They're harder.
Yeah, a couple of them were harder than the others.
Mm-hmm.
All right. So today we're going to be talking about combinations, and a combination is different than a permutation. So in permutations, we had situations where we chose R items out of n possibilities without replacement, but order was important, right? So remember, like we had first place, second place, third place, or president, vice president, and treasurer, or something like that. Now we're going to look where order doesn't matter. So in other words, if you get picked, you get picked, right? It's a good thing. So the formula for combinations is a little scary when you look at it. It's the permutation formula, and now there's division involved. So the numerator of the combination formula is the permutation formula, just n choose r. But then you have to divide it by PR choose r. And the reason you have to do that is because now order doesn't matter. So for example, if I'm picking 3 things, that and this count the same. Okay, whereas in permutations, those counted as 2 different things. In combinations, those would be the same thing because in each one, I have A, B, and C. Doesn't matter which order they're in. You still can't repeat them, but now order doesn't matter. So since we're going to divide by something, we're going to have fewer choices, right? Fewer combinations of these things, right? Okay. Now, the calculator is going to do the formula for you. Here's the formula with factorial. N factorial over n minus r factorial times r factorial. So, but the calculator is going to do it for you. Can we still use our lines? We can. We just have to remember that we're going to do division. Okay. So I'm going to give you a worksheet that you can follow along in the chat. All right. There's that worksheet for you. And now let's look at this one. In how many ways can 4 different toppings be chosen from 12 available toppings? And is this a permutation or a combination? So let's think about this. And how many ways can 4 different pizza toppings be chosen from 12 available toppings? So you have all these different toppings available. For example, maybe you have pepperoni, right? Sausage, bacon, green peppers, jalapenos, onion, black olive, mushrooms. What else do you put on pizza? We need 4 more. What else do you put on pizza?
Pineapple.
Pineapple. Oh, some people love it. Some people hate it on their pizza, right? What else? Ooh, artichoke, Jinde says. I don't think I've ever had that on a pizza. Do you like it, Jinde? That's a no. It's nasty. I've had anchovies, but not artichokes. Anchovies are nasty, right? I agree.
Ham.
Oh yeah, anchovies and ham. So do you see, like, it doesn't seem unreasonable. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We came up with 12 toppings. I'm sure there's even more that we didn't even put on here, right? Basil, AJ says. So it didn't ask for different cheese toppings, just toppings. So first we have to decide, is this a combination or a permutation? What do you think?
Combination.
A combination. Why is it a combination? Any idea why it's a combination?
The order has something to do with the order.
Yeah, so does order matter or does it not matter?
It don't matter.
It does not matter. You are correct, because I don't care if you put the pepperoni on first, right? Let's say you pick pepperoni, jalapenos, onions, and mushrooms. I don't know if you would eat that pizza, but there you go. Let's say you pick those 4 items. It doesn't matter if mushrooms got picked first or last, it's still on your pizza, right? So this is where order doesn't matter. This is a combination. It's different than a permutation. A permutation would be like when I pick first place, second place, third place, fourth place, or when I pick president, vice president, secretary. Or remember that piano recital one where it mattered if I play the song first or if I play the song last? Yeah, so that's different. So this is a combination. So now here's what I want you to think about. So this is a combination, and we're going to calculate it, but we're going to think about it a little bit differently. So we're still going to have 4 slots. But remember how we have a denominator in this one? Remember how we have a denominator in this one? Okay, so on our first spot, how many things can we pick from? How many items can we pick from?
I'll go. The first one is 12.
Yeah, the first one, we have 12 choices. And we were picking 4 total. So we had 4 things to pick from. Like we had 4 different toppings that we were picking. So, and out of 12. So now, just like a permutation, we're going to go down to 11. But now I only had 3 things that I was choosing, right? So, and then we're going to go down to 10. And now we only have 2 toppings that we're choosing. And then we're going to go down to 9 and we're going to say 1. So do you see how the numerator is just like what we did with permutations? 12 times 11 times 10 times 9. But now we have to divide, and we start with how many things we were picking. So remember, we were picking 4 things, and then we're going to go down 4, 3, 2, 1. Okay, and that's going to eliminate all those duplicates, right? Where if I have these 4 items, it's going to get rid of if I had mushrooms first and then pepperoni, jalapenos, and onions, or if I had onions first and then I have pepperoni, jalapeno, and mushrooms. Okay, so the only difference is I'm going to be dividing by things. So do this on your calculator. 12 times 11 times 10 times 9 divided by 4 times 3 times 2 times 1. Now, be careful that you use parentheses if you're using a calculator like this, so it knows which one is the numerator and which one is the denominator. Or you can use Desmos calculator because you can definitely see what's in the numerator and what's in the denominator. Okay, so do that calculation. I'll give you about 30 seconds for everybody to do it, and then you're going to put your answer in the chat. All right. Did you get it in the chat? Let's do it. 3, 2, 1, go. Very nice. So that was really, do we know how to put it in our calculator correctly, right? It's 495. So, because sometimes you don't get the same answer, right? Because our fingers slip or we forget to write something or something. So we could go here and we could say 12 times 11 times 10 times 9 times, oops, that was it. So, and then be careful because see, if I just do divide right here, do you see how it's only dividing the 9 by that? So you have to be real careful. If on Desmos you're doing it, you can do 12 times 11 times 10 times 9, or, and then hit your division bar like that. Or you could do this and say, you notice I hit the fraction button first, 12 times 11 times 10 times 9, and then I can go to the denominator, 4 times 3 times 2 times 1. So on Desmos, it's a little bit easier to control, but you can still make mistakes. So be real careful with that. The other one is this one. Remember, we had this calculator. So you could do 12, choose 4, and then we could solve. And there's our 495. Notice now it's on NCR instead of NPR because it's a combination, not a permutation. Notice how many more permutations there are than combinations, right? There's a lot more. Okay. The other place you can do it is in Desmos. On this function part, you can choose NCR and then do 12 comma 4, and it'll still give you that 495. Okay, you can also do it on here, right? On your graphing calculator. This you have to put in 12 first, then hit math and go over to the PRB menu, arrow down to 3, and now your screen should say 12 NCR, and then hit 4 and hit enter, and you should get 495. Okay, so I don't think the mathematics is hard because the calculator does all the work for you. What's hard is when you see the test, it's going to just give you questions and you're going to have to know, oh, is it a combination or is it a permutation, right? That's the hardest part. Okay. And so we got 495 ways. We could have done it with the formula. If you like formulas, this is how it works on the formula, using the actual numbers. So this is on your formula sheet. So if you like that, you can use the formula. You just practice on your calculator. Okay, let's look at this one. In the 650 lottery game, a player picks 6 numbers from 1 to 50. How many different choices does the player have if order doesn't matter? So, and it should make sense that order wouldn't matter on this. If your number gets picked, it gets picked, right? So you're good either way. So it doesn't matter if your number gets picked first or picked last, your number gets picked. So if we try this one, we can draw our 6 lines. And we're going to be multiplying all of these. Okay. So what do you think goes on these lines? What do I start with in the numerator and in the denominator? Valerie knows. Thanks, Valerie. Anyone else know what I should start with? Amanda, what number should I put right here on this first line?
50.
Very nice, 50, because that's how many things we have total. We have 50 numbers to choose from. Angelina, what would I put in the denominator? Angelina says she's not sure. Can anyone help out, Angelina? What do you think goes in the denominator? Jen Day, very nice. There's a 6 in the denominator. And there's a 6 because that's how many total numbers we're choosing, right? We're only choosing 6. So for my first lot, I have 6 different things. Then I'm going to go down in both my numerator and denominator. So I'm going to go 49 over 5, 48 out of 4, 47 out of 3, 46 out of 2, and 45 over 1. Does that make sense? Good job. So remember, this denominator, what that's doing is that's getting rid of all those duplicates, right? So for example, if we picked the number 9, it doesn't matter if we picked the number 9 first or if we picked the number 9 last, the number 9 got chosen. So we want to get rid of all those duplicates. Angelina, does that make sense? Okay. So let's see what you get when you multiply all of these. This is probably going to be a pretty big number, right? So do this on your calculator. I'll give you about 15 seconds because you're getting better at it. And then we'll put it in the chat in just a sec. All right, let's put it in the chat. 3, 2, 1, go. Very nice. It feels better when you get the same answer as someone else, right? Good job. So that's a really big number, right? 15,890,700. So, and I just showed you with the formula here. But now I have a question. So in this problem, those were all the different ways we could select 6 numbers out of 50 numbers, right? So now what if I change the question and say, what's the probability that I win this lottery? I get all 6 numbers correct. What would the probability be that I'm going to win? I'm going to get all the numbers correct. Any ideas? What do you think? Malachi, Amari, got any ideas? Where did you get 12%, Amari? Oh, so, but these are all the ways that I can choose 6 numbers. How many ways will be correct? How many 6 number options will be correct out of those 15,890,700? There's only one that's going to match, right? So my probability of matching all of the numbers is 1 out of 15,890,700. So your likelihood of winning the lottery is very, very, very low. Yes, in case you didn't know that. Now, sometimes you win if you don't match all 6, right? Sometimes you win if you only match like 4, but you don't win the big prize. You just win less. Does everybody understand why it would be 1 over that 15,890,700? Malachi, does that make sense?
Yeah.
All right. So what if we have a daily lottery game? This time you're picking 3 numbers from 0 to 9. How many different choices does the player have if order doesn't matter? I'm going to give you guys a minute or so to do this all by yourself. So we're not doing probability. We're just asking how many different choices does the player have if order doesn't matter. So think about that, and then I'll have you put it in the chat when you're done. All right, are you ready? Let's get this answer in the chat. 3, 2, 1, go. Very nice. 120. So how did you get 120? Amanda, what did you do?
I set up the fraction, so I did 10 over 3, and then 9 over 2, and then 8 over 1, and then I multiplied them together.
Excellent. And how did you know it was 10 as your first numerator?
Because 0 is included, so you have to make sure that you count the 0.
Very nice. Instead of 9 numbers, there's actually 10 numbers there, right? 0 through 9. Okay, good. And then in the denominator, Malachi, how did you know to put a 3 in the denominator on the first fraction?
You have 3 choices.
Very nice. 3 choices for the first spot. You know, you're picking 3 numbers, then 2 numbers, then 1 number. So good job. Excellent. So, but you can see how when we put these pieces together, it can get confusing, right? When you have both combinations and permutations. So be careful on that. Okay, we can compute probabilities. We've talked about this. So look at this question. It says, what's the probability that if we type 6 letters at random, no letters are repeated? So what's the probability this time? So remember, probability is successes over total. So think about that. And there's 26 letters in the alphabet. Okay, so this one's a little bit different. Okay, 26 letters, no letters are repeated. Think about that. I'm gonna let my cat out. All right, so these get a little bit trickier, okay? Because it didn't just say, you know, how many ways can we choose this much out of this much and something like that. So let's think about the successes. Well, you can draw your lines for the 6 letters that we're choosing. 1, 2, 3, 4, 5, 6. So how many choices do we have for our first letter? AJ, how many choices for the first letter?
26.
Very nice. 26. Now, we're just counting how many total we have, right? So we have 26 for the first one, 25 for the second one, 24, 23, 22, and 21. But this is actually a basic counting principle. It's not a combination, really. It's a little bit trickier because we're not choosing a specific number out of a specific number, but we're thinking of probability. I want you to think about what are the total possible ways or the total possible letters that we could pick. This goes way back, like way back to the first section on probability. So if we're counting all the possible ways, we would have 26 choices for the first one, 26 for the second one, 26 for the third one, 26 for the fourth one, 26 for the fifth one, and 26 for the last one. So our denominator would be 26 to the 6th power. Do you see how probability works differently than a combination? So these get a little bit trickier. So this is what your answer would look like. What's the probability that if 6 letters are typed, no letters are repeated? So this doesn't sound like a combination anymore, like we were doing. Since we have probability, we have to look at this total amount. Do you see how that one's a little bit different? Yeah. Okay, how about this one? So 5 letters are typed. You can repeat. What's the probability that all 5 will be vowels? All 5 will be vowels. So think about it. So you have to figure out the numerator's choices, and then the denominator is the total. All right. So what do you think the numerator is for this fraction? What do you think the numerator is? Okay. I like how we have a 5. So if we're drawing 5 lines, 1, 2, 3, 4, 5, we have 5 choices for the first one because A, E, I, O, and U. There's 5 vowels. And it says repetition is allowed. So how many choices for the second letter if we want it to be a vowel?
Would it be 5 again?
You got it. So they're all going to be 5 in our numerator. So our numerator is going to be 5 times 5 times 5 times 5 times 5 times 5. Now, how many total possible ways can we arrange the letters in the alphabet if we're choosing 5 of them, and we can repeat. So what would our denominator be? Malachi or AJ, any ideas?
Wouldn't it be 26? It's repeating.
Yeah, 26 5 times. So really you have 5 to the 5th power over 26 to the 5th power. Any questions on where I got those? That's all right, Jende. At least you put it out there, right? You're fine. Any questions on where those came from? So if you do this on a calculator, you're going to get a pretty small number, right? Anyone do it on their calculator? You get a pretty small number, right? Okay, so let's take a look. If we do 5 to the 5th power, oops. 5 to the 5th power divided by 26 to the 5th power. Oh, and some of you might have had this happen on your calculator, right? I can give you a fraction. There's the fraction. But remember when we got something like this? 2.6301 blah blah times 10 to the negative 4th. So let's look. If you do 2.630, can't remember what it was, 16674 times 10 to the negative 4th. This being a negative makes your place value shift to the left 4 places. So 1, and then I'm going to add 3 zeros. So I'm going to get a 0, a decimal point, 1, 2, 3, 2, 6, 3, 0. And I could keep going 1, 6, 6, 7, 4. So that's what I wrote. I just wrote 0.0002630. That's a really small number, right? So the probability that if you type letters at random out of the 26 letters, the likelihood that they would all be vowels would be less than 0.02%. That's a really small chance, right? Questions on that one? All right. The last thing I want to talk about today in regards to these is more lottery games. But the lottery games are going to look a little bit different. So do you see how a player picks 6 numbers from 1 to 48? But now they're telling us something new. They're telling us if you get 4 of the 6 numbers, you win 3rd prize. Okay, so you don't have to match them all. You only have to match 4 of them. So we want to find the probability of winning 3rd prize. Find the probability of winning 3rd prize. That's what we want to do. Okay, so remember, your denominator is going to be all the possibilities there are. Okay, the numerator is going to be how many ways you could win that. So first, just think it through and see if you can make sense of what's happening. Okay, because this one's a little bit trickier. All right. How are you guys doing thinking it through? Because this one's kind of difficult. So somebody just tell me what they're thinking, like any information you can give me about how you're going to go about solving this. How many numbers are we picking?
6.
We're picking 6 total, yeah? So let's just draw 6 lines to make sense of it. 1, 2, 3, 4, 5, 6. Okay. And let's not worry about the 4 right yet. Okay, let's think about that in a minute. What I want to think about is, remember probability, our denominator will be all possibilities, right? Or the total. I can't write possibility. So how can we figure out all the possible ways that we could choose 6 numbers out of 48 numbers? Does that sound like a combination or permutation? What do you think? All the possible ways you can choose 6 numbers out of 48 numbers. Does order matter or not matter? I think Amanda's shaking her head. It doesn't matter. How many of you agree that it doesn't matter? The order doesn't matter. Yeah, the order doesn't matter. It's just a lottery. If you pick the number, you pick the number. If you don't, you don't. So this denominator must be our combination 48, choose 6. Do you agree? And for 48, choose 6, I could do 48, 47, 46, 45, 44, 43, all over 6 times 5 times 4 times 3 times 2 times 1. So everybody see that that's going to be our denominator. C48, choose 6. That's going to be our denominator. Okay, what is that number? C48, choose 6. Do that math. Let me know what you get. You can just put it in the chat. One, two, two, 7, 1, 5, 1, 2. You get used to putting those commas in there, right? So 12,271,512 possible ways to pick 6 numbers out of 48. So that's our denominator. Those are the total possibilities. You okay with that? All right. So now the numerator is kind of the hard part because it's a little bit trickier than it was, because we don't want to get all the numbers right. Well, we probably do, but that's not what the question's asking us. The question's just saying we only want to get 4 out of the 6 numbers right. Okay, so we're not going to match all of them. So I'm going to ask you a different question related to this to see if I can help you. So how many ways are all 6 numbers correct? Are there 50 ways all 6 numbers are correct? Are there no ways? So what do you think? There's just one way that all 6 numbers are correct, right? There's just one way. Now, Valerie, what were you answering with 15? Let's think about that. What were you answering with 15? So remember when we talked about what's the probability? So if there's only one way it's correct, yeah, so C6 choose 6 is 1, right? But that's not what our question asked. We don't want to get all 6 correct. So Valerie put in there 6 NCR4, which is 6 choose 4, because we only want to get 4 correct. I mean, we don't really want to just get 4 correct, but that's what the question is asking us. So, and Valerie's right. If I do 6 choose 4, I'm going to get 15. And you might say, where does that 15 come from, right? So if we're choosing 4 numbers out of 6, we would get 6 times 5 times 4 times 3 as our numerator. And then our denominator would be 4 times 3 times 2 times 1. So we get 360 divided by 24, which is 15. So there are 15 ways to get 4 out of 6 numbers correct. So the reason I drew those 6 lines was for you to think about, I want 4 of them correct, and then I don't care if 2 of them are wrong. But it doesn't matter where those 4 are correct, as long as I have 4 that are correct. So when Valerie was doing C6 choose 4, those were her correct ones that she was picking, which would be 15. Now, but I only picked 4. So now I have to pick 2 that are not correct, or 2 wrong ones. Yeah? But how many numbers am I choosing from if they're not correct? If I have 48 total numbers, and I know 6 are correct, how many are incorrect? There you go, 42. So there must be 42 that are incorrect. So out of those 42 numbers, how many do I need to pick? I already picked 4. I'm picking a total of 6. So how many more do I need to pick? 2 more. So this is my numerator. C6 choose 4 and C42 choose 2. So on my 42 choose 2, you want to think about it. You're going 42 times 41 divided by 2 times 1. So what'd you get for that part? Did you get 861? So if I multiply this, I'll get 12,915 over 12,271,512. So now you can see how the lottery problems get much more involved, but it's a strategy that you have to talk through and understand. If we made this a decimal, it would be pretty darn small, 0.001052437 right? So there's only a 0.1% chance that I'm going to get 4 out of 6 numbers correct, let alone all 6 numbers correct. So this is what it looks like in combination language. So it would be C, I'm going to write it right here. C6 choose 4 times C42 choose 2 divided by C48 choose 6. And if you make sense of it, the denominator is I'm choosing 6 numbers out of 48 numbers. This would have been like the start of our day today, just the denominator, okay? The numerator, this is a really complicated one because I want to choose 4 of the 6 correct numbers, and then I want to choose 2 of the remaining 42 numbers that are not correct to figure out my probability of winning third prize. Okay, so that one's really complicated. All right, so you have homework to do tonight. The reason I'm stopping right now is because I want you to have time for the exit ticket, but I also want to talk to you about a couple of things. I'm going to give you this worksheet tomorrow. We're going to work on it in class. We're finishing up combinations tomorrow. Don't forget to do your more practice homework. You have your probability review video that's due tomorrow. How many of you have done your problem from the probability review? Amanda did her problem. Anyone else? Valerie did her problem. No one else? Does everybody know which problem they're supposed to do for the video? AJ, do you know which problem you're supposed to do for the video?
I think I forgot. I'll write it down somewhere.
Okay, well, you can click on the document, but you're in charge of question 3 under PC7 combinations. Valerie, you said you already did yours. Ashley, what number are you in charge of?
I was literally just checking on the thing you just said.
Okay, so you're in the third one down in the table. So you're in number 1, the third part. Malachi, which part are you in charge of?
Uh, I thought, I don't know, to be honest, but I think it was like 6 or something.
Nope, 2B.
All right.
Amari, do you know which number you're in charge of? Okay, it's PC6, number 1. Amanda, you already know yours. Angelina, which number are you in charge of?
The last one.
Very nice. The very last one, which is a lottery one. And so that one's very similar to what we just did, but a little bit easier because you're winning all of it. So there's only going to be one way to win it all, right? So you have to just do your denominator. Jen Day, how about yours? Do you know which one you have to do?
Yeah, I was number 1.
All right, good. So if you don't make your video, you're going to get a 0 on that assignment. But worse than that, you're not going to be able to help the rest of the class study for the test. So you do all the problems, then everybody's going to post their videos. Then you're going to be able to watch the videos and see if you solved it the same as someone else. That's the idea behind this. Okay. I also have an optional extra credit assignment. It's quizzes. So you can do it, just put your name in there when you do it, and you have to complete the whole thing. Don't forget to study for your quiz because you do have a quiz this week. Okay. All right. So I'm going to put the exit ticket in the chat. If you want to stay around because you have questions, you can. We still have about 9 minutes. So I just want to make sure if you want to look at your question right now, you totally can. make sure you realize the exit ticket is a probability question, so your answer will be a fraction.